2889, Duck Duck Goose, I mean pipe. If this is a class that you signed up for, great. If not, feel free to go ahead and take off. But my name is Daryl McClelland. I am the BIM and Virtual Design Manager at HEPE Engineering. My co-presenter today is Adam Bryson, and he is the BIM Coordinator at HEPE Engineering. So one of the first things that I want to cover today is basically just kind of summarize the class. How many people in here attended the keynote this morning? Okay, so you guys saw Lynn Allen. She said that there's 800 classes. It's a lot of classes to choose from. I know when I was filling out my schedule, there were a few things that I was on the fence with. Do I take this one? Do I take that one? One of the things that I want to do is cover at a high level some of the topics that we're going to go into, because if you guys actually had another class that you were on the fence with, you have the opportunity to take off, and I won't be offended by that. But I just want to cover some of the things that we're going to go through so you guys get a clear understanding of what we're going to talk about. So we're going to focus on the ductwork and piping tools within Revit MEP. And we're going to take a look at the calculations within Revit MEP, those ductwork and piping calculations. Adam and I are kind of responsible for training our staff in our company, and one of the things that we struggle with is getting complete adoption with the product. We have a lot of engineers who are set in their ways, a lot of engineers that don't want to give up their duculator or system sizer, don't want to give up their tables and charts. And when you approach them to say, hey, you know, you can put that down, you can go ahead and do some of these ductwork and pipe sizing inside of Revit MEP, you get the cross-eyed stare and go away, I'm busy. So we've kind of broken it down to help relieve some of the angst from our engineers, and we're going to go through that process just to kind of show you guys what is going on within Revit MEP. We're going to take a look at the system inspector, take a look at the duct and pipe pressure loss reports, and we're also going to take a look at some color fills real quickly so that you can confirm some of those analysis tools, how you laid out your piping and ductwork and other things like that. So at the end of this class, we are hoping that you're going to have a better understanding of that calculation aspect. We're going to talk about things that are going to negatively impact your model. So in order to use the calculations, you have to do some things within Revit MEP. You have to connect your systems. You have to watch out for warnings. We're also going to talk about some, how do I want to say this? Help me out here, please. You're David. If you have an object that has legs crawling across the floor, what is that? A what? Now, an object that's on the floor, crawling across it, lots of legs. Who said what? I heard bug. Did you say bug? Okay, so you are, what's your name? Mike Hutchinson. Mike. So Mike said bug. I did not. So we're going to talk about some bugs in the product that we have found in the 2013 product. Okay, how many people are using 2013, by the way? Okay. All right, so you guys may have discovered some of these bugs. We're going to share some of the things that we have found and some of the tips to overcome those bugs. I'm going to refer to those as performance warnings. Trying to be politically correct here. But then we're going to take a look at how some of these tools in Revit MEP can allow you to be productively lazy. I personally like being productively lazy. Yes, you do too? Yeah, and I like your name too, by the way. Yeah, so Danielle, I thought it was Daryl. All right. So with that, help me understand where you guys are, because the hardest thing when you're putting together these classes is when you attend the class is getting something out of them depending on your knowledge base level. So how many people, and I'm going to say that a beginner in Revit MEP is 1 to 3 years. How many beginners do we have in here? Okay. Let's say intermediate level is 3 to 5. Advanced, more than 5. Okay, so we have a few advanced. So hopefully, Adam and I are hoping that at the end of this presentation, you can at least take one thing away that say, you know, I didn't really know that. So that's our overall objective of this class. So we put together an agenda and these are some of the items that we're going to discuss. And so we're going to go through some introductions. We're going to talk about some housekeeping items. We're going to talk about a potential training resource for you guys. We have to do training inside of our company. There's not a lot of training tools that Autodesk produces anymore. As a matter of fact, it's next to none. We're going to talk about what an engineer is. That will set the stage of what we're dealing with to drive adoption with the engineering types within our firm. And then we're going to break that down to ductwork calculations and piping calculations. And we're going to see how those apply to Revit MEP. We're going to get into the product under helpful tips. So we're going to talk about some tips that we believe that will help make some of you guys more successful. We'll talk about the performance warning or the performance warnings, the bugs that Mike called them. I didn't call them bugs, but what Mike called. And then we're going to get into some of the duct and pipe tools. So with that, just real quickly, my role within my organization is twofold. 95% of my time is spent in technology. I have a technology playground. I basically look at new technologies, figure out whether we can implement those, roll those out, create workflow processes, modify workflow processes, and some other things. I did graduate from Purdue University. In my spare time, I don't fish, I don't golf, I don't do any of that. I write books, and I have written 6 books that have been published nationally. And I've got 27 years of experience behind me in the MEP field. So with that, I don't like talking about Adam in front of him. I like talking about him behind his back. But I'm going to let Adam go ahead and introduce himself.
Yes, my name is Adam Bryson. I also work at EP Engineering with Daryl, and I'm mainly in charge of our Revit library, taking care of all the family creation for our company. And I also get heavily into the schedule creation and also any of our standardization that needs to take place within the product. I'm also with Daryl in charge of trying to train everybody in the company. And as it says up there, I'm a recovering Revit junkie. I've been out of the product for 5 days, and now I'm back in it again, so I got to start that timer over. And I've got 11 years of architectural and engineering experience. I've only been in the MEP field for about 3 years now. Prior to that, it was all architectural discipline stuff. Thank you.
Let's not hold that against Adam, okay?
Yes, please don't.
All right, so a couple housekeeping items for everyone. If you can, just take a moment to make sure that your cell phone is turned off or set to vibrate or silent, just as a courtesy to everybody else in the room. If you do need to take a call, please step outside to do so. A few years ago, I taught a class. Somebody sitting right over there, first row, very corner, phone rings, hello. So please take the call outside the class. We have posted the handout. We have posted the presentation. I have caught a couple things on the presentation that are incorrect. I will be reposting the presentation. I will also repost anything that I think is incorrect or that you guys bring to my attention and handout that might be incorrect. I'll do that within the next couple weeks. This class is being recorded, so please be on your best behavior. I primarily put that up there for Adam. But if you can, just try to keep any chatter or conversations down when questions are being asked, because those can be picked up on the mics. And then finally, class evaluations. They're out in the center core out there. If you guys need any help, Adam and I will go out of our way to help you. Just send us your URL link. We'll go ahead and fill out the survey for you. So we don't want you guys to be burdened. You can spend more time at the gambling, establishments, but we'll be happy to do that for you. So again, one of the things that we struggle with internally is finding training resources for our people. We'll get somebody hired. They may have a great Revit knowledge base. They may just be a beginner. So one of the things that we end up doing is we actually use this book, and we can basically assign people particular chapters. It comes with data sets and some other things. I do have 6 of these books up here. I will be giving these away. These are some of the books that I've written. So if you guys have business cards and you're interested in this, pass your business cards down to the end and then pass them forward, and we'll go ahead and have a drawing periodically throughout this session. I attended a CFD session this morning, and they actually gave away bottles of alcohol, so I feel a little, I don't feel like I have helped out here. So, as a matter of fact, one girl, the guy had multiple bottles. One girl said, "I'll take whatever," and then somebody else said, "Are you sure she's over 18?" So anyway, so let's talk about this. What is an engineer? And the reason why I'm going to talk about this is because I'm going to set the stage for some of the things that we struggle with. You guys may be struggling with the same thing in your organization as far as how to deal with people who are set in their ways and trying to inflict change, not pain, but change on them. Okay? So what is an engineer? Typically, if we can't see it, we can't smell it, we can't touch it, we don't believe it. Okay? That's just the way we're wired, in summary. By a show of hands, how many engineers do we have in this room? Okay. So I'm going to pick on Tori. Okay, I'm going to pick on you, Tori, if you don't mind. So let's say you and I work. First of all, have we ever met before? I don't think so. Okay, great. So we've established that we've never met before. So if you and I work together, and you have some spreadsheets that you've used over the course of years, and I come up to you and say, you know, Tori, there's 12 things that you have to input to get this answer. I've got a spreadsheet that can do it in 2. Here, let me give it to you. Would you use it? So Tori's answer would be, he would probably pick it apart. How many engineers in the room would agree with that? Yeah. We are non-trusting. Again, if we can't see it, touch it, we don't believe it. Okay? So why is that? Tori, why is that? We like to know. You like to know. If I come up to you and I say, you know, Tori, based on your spreadsheet, I have a piece of software that will do the same thing. Why don't you use it? What would you do? What would you say? Okay, so you're not going to blindly use it, correct? All right, everybody in agreement with that? So these are the things that Adam and I struggle with internally, is how do we overcome that? So we have to hold hands with the engineers. So we're going to talk about this. Now, why is it that engineers just don't blindly trust this stuff? Who said what? It's wrong. Man, I think you're taking a shot at Tori and I, but why is that? I heard some liability, right. That's clearly it. We have liability, we have a career, and we have a reputation. Okay, those are 3 things that are very tough to overcome. Okay, so again, let's go back to that holding of the hands that we're going to be doing here. So, with the constraints of projects, does anybody, Tori, do you have time to reverse engineer this spreadsheet that I just gave you?
Well, if you pay me for it,
Why is it about money, Tori? Okay, so Tori basically said, if you pay me for it, I will do that. But who has time to do that? That's exactly what we face. Nobody wants to take the time to dive into this, to figure out exactly how this software ticks. So therefore, what are they going to do? They're going to stay and stand by their tables, their charts, their duculator, and their system sizers. Okay? All right, so remember, if they can't see it, they can't touch it, they can't smell it, they're not going to believe it. All right, so if you're doing things where you have to grab a mouse, draw some things, put it down, consult a duculator, consult a system sizer, look at a table, look at a chart, you're adding some time to your projects. Everybody agree with that? If you can keep your hand on your mouse and you can just design away and grab a section of duct or pipe and say, you know what, I want you to size this based on the flows that I've assigned to this, you're not having to start, stop, start, stop, start, stop, right? Everybody thinks it's a little bit more efficient if you can keep working. Correct? This means I'm falling asleep because the lighting level in this class is down low. All right, so that's kind of what Adam and I are working with, and you guys may be in the same boat as well. So let's talk about the ductwork calculations. So one of the things that we have to do is we have to go to the engineer and we have to say, basically, we understand how you size your ductwork system. So I'm not going to spend a lot of time going through this, but it just does set the stage for what goes on inside of Revit MEP, which is what we're going to talk about. So we have to go to the engineer and we have to say, we understand that you size your ductwork based on velocity. It could be friction and velocity. It could be equal friction. It could be static regain. Everybody in agreement with that? You're not just going to do this with a ductwork system, right? And you know, for everybody who can't see this, that was the rule of thumb. Of course, it's being recorded, so you don't get full effect of that. You could go to tables and charts, right? You could look at tables and charts. What are those tables and charts based on? Well, if you open up ASHRAE 2009, Chapter 21, it's basically going to say that the tables and charts are based on standard temperature and standard pressure air. That means dry air. So 70 degrees, 0% at 14.7 psia, which is also affectionately referred to as sea level, okay? Well, what happens if you don't have 70-degree air? I'm not delivering 70-degree air as my supply duct. My return may not be 70 degrees. My exhaust may not be 70 degrees. Well, what happens? Well, ASHRAE specifically states that, hey, guess what? We'll give you plus or minus 30 degrees on either side of 70. We'll give you to an elevation of 1,500 feet, and we'll give you plus or minus 20 inches in that ductwork system before you're affected by 5%, okay? So 5% probably isn't a whole heck of a lot when engineers use a 50% safety factor, correct? Do we have any architects in the room? Oh, I'm sorry. That's secret. I probably should have asked for the architects in the room. You didn't hear that, okay? We don't use 50%. We just size it the way it's supposed to be sized. Okay, now that information, again, is straight out of 2009 ASHRAE, okay? That's, again, some of those things that we have to cover with the engineers. So when you pick up a ductulator, everybody seen one of these? When you pick up the ductulator, and mine's old, mine's old, so am I. Down in the lower left-hand corner, it will actually say, the newer ductulators don't say this, but down in the left-hand corner it says, hey, this is based on 0.05 pounds per cubic foot, derived out of Chapter 32 of the 93 ASHRAE fundamentals. Okay? So remember the 0.075, all right? Just remember that as we move forward. All right, so basically the ductulator says straight out of ASHRAE, all right? So what are those formulas and charts based on? Well, straight out of ASHRAE again. If you look inside of ASHRAE, it's based on the Darcy or the Colebrook equation, laminar or turbulent flow. And it basically says that the friction loss can be defined as this formula down here, 12 FL over the hydraulic diameter times rho times velocity squared divided by 1097 squared. Okay? So that's what we're going to focus on. That's what we have to basically confirm with the engineering types of, hey, based on ASHRAE, based on things that are going on in your life, this is the formula that you use. Once we get buy-in on that, now we can proceed to how all that is incorporated into Revit. Now remember, the overall objective here is to try to create more efficiencies. How many people's fees in the last 3 to 4 years have gone up? Wow. Well, I said fees. Project fees. How many project fees as far as what you can bill out or what you can invoice have gone up in the last 3 or 4 years? So very few people in here. Okay, so what becomes a combative measure to offset that? Trying to be more efficient. Okay, so there's little efficiencies. You buy this product, well, why use it just to throw a bunch of lines down on a piece of paper? There's other tools in there that can help you be more efficient and also can lead to project profitability. Okay, so let's take a look at that. We're going to focus on this equation. What is F in the equation? F is the friction factor. It's based on Moody's chart. Okay, F is basically the roughness of an object. So does Revit MEP incorporate the roughness of an object? Yes, it does. If you actually go into the type properties of the particular ductwork system, you can actually assign a roughness factor for that ductwork system. So whether you have galvanized steel, carbon steel, PVC, concrete, what have you, you can actually assign that to that type of ductwork system. So Revit MEP incorporates that friction factor inside of the product. Okay? So what is L? L is the length. Does Revit MEP incorporate the length into the product? Sure. Draw a pipe, draw a duct, what have you. Select that, go to the properties palette, you're going to see the length listed. Okay, so we're almost there. So we've covered two things. So let's talk about the hydraulic diameter and row. Does Revit MEP incorporate the hydraulic diameter? Yes, it does. If you grab that piece of duct, it will actually tell you what the area of that duct is. And it will calculate the perimeter of that ductwork as well. What's it based row on? Well, remember, row is based on the standard temperature, standard pressure of air. And that's straight out of ASHRAE. And if you remember, we talked about this. What was the number that we had on that ductulator? Basically, the 0.75. So again, the ductulator says 0.075. Row for the calculations for Revit MEP is based on 0.075. So again, we're still in sync. Okay, so hopefully by this time the engineers are feeling a little bit more relieved. We can actually begin removing our hand from their hand and helping them stand on their own. All right, so velocity. Does Revit MEP incorporate velocity? Yes. If and only if you have assigned a flow and connected your duct and pipe correctly. Okay, that's the key component. All right, if you don't connect things correctly, you're not going to be able to take advantage of these. As a matter of fact, if you don't connect things correctly inside of Revit MEP, you are causing more harm to your model. We'll talk about warnings later. All right? So, with all that said, does Revit MEP incorporate the ASHRAE formula, the Darcy formula inside of it? Yes, it does. As a matter of fact, if you dig deep into the help menu, it's clearly outlined. If you notice, we have been talking about this formula right here straight out of ASHRAE. That's the same formula that Revit uses to size its ductwork. Okay? So these are some of the things that we have to go through with our engineering types just to bring a sense of comfort to them that it's okay. You can put down the ductulator. If you connect your system correctly, these are the tools that you can use. And oh, by the way, are you tired of working until 9 or 10 o'clock at night? Wouldn't you rather go home at 5 or 5:15? All right, so let's continue on. Oh, one last thing. What's the big kick to this? The big kick to this, and this is a quick tip for you guys, is that remember, standard temperature and pressure of air is already set inside of Revit MEP. So if you're dealing with that 70 degrees plus or minus 30 degrees on either side, which gives you 40 and 100 degrees, you don't need to make any changes. But if you're dealing with air that's colder than that or warmer than that, opposite ends of the spectrum, you're going to have to make some changes. But if you change the air density and the air viscosity for the air that you have, it's a global change. It's not a system-by-system change. And we'll talk about some system-by-system changes for the piping side. But remember, that's just a quick tip for you guys. If you make that change, it's going to affect everything in your project. Okay? So just understand that. All right. Did you collect business cards? So with that, first book goes to Tori for being such a good sport. Second book, Tori, we're going to go ahead and put Tori's name up here since Tori won. Any card. All right, and you guys can be mad at Tori if he didn't select your name. That's why I handed off that responsibility there. We have, great, Tricia Reed. All right, so Tricia, I'm putting your business card in this book up here. Come up and pick it up afterwards, after class. So we're going to set some ground rules, so you do have to be present to win. And you cannot win if I hear you make disparaging comments towards Adam or myself, or if you throw objects at either Adam or me. Okay? All right. So let's talk about piping calculations. Again, same conversation. I'm going to quickly walk. Yes, question. Ductwork calculations, yep.
My experience is tell Revit size velocity, equal friction loss or any method. It's going to go down. I know that some ducts are 4 inches, but I know they can be 2 inches if you have 50 cm, whatever. The same goes for pipe. Revit's going to start sizing every duct 3 inches. I cannot limit that. I want to limit that. So I'm running into this a lot. I don't know if this works without that.
You actually can limit that. You can actually go into the mechanical settings, into the, I would have to go back a couple slides, but there's the sizes, and you can basically, there's 2 columns, and it's the used in sizing and used in drop down, or I can't remember what it is, but if you deselect those, so for example, when I lay out ductwork, I prefer not to see any odd sizes. So I'll go through and actually remove all the odd sizes out of there. Remember, that's a project-wide setting or project-wide setting. So if you have other folks that, there we go, thank you. So that's why I brought Adam along. I'm only kidding. So yeah, so actually if you go into the mechanical settings, then you can control that based on the ductwork type, so rectangular, oval, round, and you can basically just exclude that out of your sizing. If you actually check both those check boxes in there, when you go to the drop down, you won't see the 3-inch size. That doesn't mean that it's not available. All you have to do is type in 3 and it will still put the 3-inch size in there. It will go to the next size up, yes. The question was, will Revit go to the next size up? The answer is yes, it will go to the next size up. Okay? All right. So let's move on very quickly to piping calculations. So we're going to talk about how engineers size their piping calculations, very similar to what we did with the ductwork, and then we're going to apply that to Revit MEP. So understand that, so when Adam and I talk to the engineers, we basically tell them that we understand that you can size your piping system based on velocity, based on friction, based on a combination of both. We also understand that you guys have tables and charts that you may use. So we also understand that there's some other items, and we'll talk about that in a second, about with the system sizer. But what are those tables and charts based on? Again, digging out the Mechanical Engineer's Bible. ASHRAE, if you look at chapter 22, it says that those tables and charts are based on 60-degree water. Okay, so what happens if you have something that's more than 60 degrees? I have a heating hot water system. Am I going to be running 60 degrees in it? Probably not in the winter. Maybe 180, 140, 200, somewhere around there. So what's going to happen? Well, unlike the ductwork, with 5%, you could get an error up to 20 or exceeding 20% straight out of ASHRAE. Okay, so we're going to talk about that inside of Revit MEP. And as I mentioned, you know, there's some other tools, System Sizer and some other things. So again, what's the formula in ASHRAE based on? Well, you know, Henry Darcy was a busy guy, so he partnered this time with Mr. Weisbach, and basically they came up with a formula that basically says that the pressure drop within a pipe can be summarized by F times LD over rho times GC over V squared divided by 2. And we're going to start breaking that down here within Revit. So let's take a look at F. What is F? Well, F is friction factor again. Okay? Can a friction factor be applied to piping within Revit? Yes, it can. If you go to the mechanical settings and you get into the segment and sizes, you can actually begin to apply friction factors for the various types of pipes. Okay, so if you have carbon steel, if you have PVC, if you have copper, you can begin assigning those friction sizes inside of Revit MEP. Okay? What is L? L is length. Again, very similar to the ductwork. You draw a duct, you draw a pipe, you select the duct or the pipe, it will tell you what the length is. So that is incorporated into Revit MEP as well. What is D? D is the internal diameter, the inside diameter of the pipe. Does Revit MEP address that? Sure, go back to the mechanical settings, select your type of pipe, whether it's carbon steel, PVC, copper, what have you. You can actually go through and set those sizes for your internal and outside diameter. Okay, so again, that's all incorporated. And again, this is stuff that we have to do to walk through with our engineers to make sure that they have a sense of comfort even before they'll begin considering using those tools. All right, so let's talk about row. Row is basically boils down to the density of the fluid in the pipe. All right, so does Revit MEP incorporate row? Yes, it does, because within the mechanical settings, again, you can actually set your fluid type. So water, ethylene, propylene glycol inside that water system, you can go through and set your density and viscosity of that pipe. So again, that is, that's actually accounted for inside of Revit MEP. Now the one thing that I'll bring to your attention is the last time I checked, 30.2 degree water has changed state. So it's not water, it would be a solid. Don't know too many pumps that would pump solid ice. So within the out-of-the-box template file, if you guys really get that close in temperature, you might want to just change that to 32.0, and I do believe that the viscosity and the density will match up with that. Okay, we'll talk about what the gravity constant is here in a second. So last thing, velocity. What does Revit MEP incorporate velocity? Yes, very similar to the ductwork, if and only if you have connected your piping to that object correctly. It will actually size that, or it will actually tell you what the velocity is of that fluid in that pipe based on the size. So this all boils down to, again, digging into the help menu. And if you guys look, that formula that we have been talking about has been clearly outlined inside of Revit. It's the same formula that's inside of ASHRAE. Okay? And again, it basically states down here that the gravity constant is 32.2. Okay, so that makes a lot of sense. Those are some of the things that we have to do internally to get our engineers to consider changing. Okay? So the next couple of things that we have to do is to make sure that those guys actually connect their systems correctly, and that's what we're going to kind of talk about here. So a couple tips for you guys. What is the density and viscosity based on in the mechanical settings in the out-of-the-box template? It doesn't really come out and say, but if you do the calculation on it, it's based on sea level. So if you guys are working in Denver, Denver is what, 63 feet below sea level or something like that? All right, 5,000 feet above sea level. You're going to need to basically recalculate your density and viscosity for all your tables. Okay, so just understand that if you're going to proceed down that path using the tool, just make sure that you reassign your density and viscosity so that you can actually make sure that your duct or your piping is sized, not ductwork, but piping is sized correctly. All right, with that, yes, question? So the question is, if I actually locate my project correctly via some of the location tools within Revit MEP, will it automatically adjust the density and viscosity? The answer to that is no. The answer to that is actually no, it will not. Okay, that's one of the things that I also made a recommendation to someone internally within Autodesk. And I believe we have someone else in Autodesk who's in the room, but he'll remain nameless at this point in time. He's taking good notes on some things as well. So that's one of the things that would be helpful. It would be fantastic. It's basically, density and viscosity is a formula. It would be great if you can just, set your elevation, and guess what? Boom, all your density and viscosity are changed. So that would be great. Great. You guys are really challenging me here. Mark Hahn. Oh, well, all right. You know what? Okay. All right, so we're going to do another one. Since Mark vacated that book. Is this your friend? All right. Marcia Selim? And I took these off to try to help, but apparently that didn't work. All right, sorry about who back here? Okay, all right. And by the way, that was just a lucky pick. I mean, all right. So your book's up here, cards in it. Come up after class, pick it up. All right, let's go in. Let's start beginning some of these helpful tips that we talked about. So let's start getting into the product, and we're going to cover some things that we have found that's been helpful to us, that helps keep our template file small, that helps people actually using the product navigate through the product a little bit faster. So one of the things that I'm going to say is that don't put everything in the kitchen sink inside your template file. How many people believe in that? Okay, great. You know, it keeps the template file a lot smaller. Adam and I deal with, we're back to architects again. Adam and I deal with architects, and we get architectural files that come in that we look at them, and it's like, well, this is only 1,000 square feet, yet the file is 100 meg. So what we have to do is we have a process. We go through that process, probably very similar to what you guys do. And what's everybody do when they get an architectural file? Purge. You will be amazed at how small that file can get. So, you know, we have a theory that some of our architectural partners don't have a library. Their library is actually the template file. Because when we get their files in, we purge them out, and all of a sudden they become 5 meg, 6 meg, you know, 10 meg, something that's a little bit more palatable. The other reason that we're going to talk about this is when you start listing everything in here, how many people do multiple different types of projects that don't focus on like just solely hospitals or things like that? You're doing schools, you're doing hospitals, yeah. So is a school system going to have a medical vacuum, or a grade school going to have a medical vacuum in it? Is it going to have medical air in it? Well, then why do you want to be bothered seeing that in a drop-down? Okay, so that's one of the other reasons why we say teach your people how to put piping in, and that's one of the things that we're going to talk about. There's a couple catches there that you have to understand. The other thing that you're going to look at is graphic overrides, calculations, the fluid type. We talked about fluid type. Fluid temperature, we talked about that. The abbreviation rise drop. And as I mentioned, the key component to this is the ductwork and piping system classification. So we basically have trained everybody that if you're going to create a system, make sure you use the correct system classification. In the out-of-the-box template, you have hydronic supply, hydronic return, supply, return, exhaust, and a few other things, sanitary vent, blah, 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 blah. So if I want to create a condenser water supply pipe, what am I going to use? Hydronic supply. I'm not going to use hydronic return, okay, because the behavior of that system is going to be based on the system classification. Okay, so that's why it's imperative that you select the right one. You can't just say, well, it doesn't really matter. It does matter because it is based on the behavior of that pipe. Okay? The other thing too, how many people know about this? How many people know that you can actually shut the calculations off inside of Revit MEP? Okay? You can actually turn the calculations off inside of Revit MEP. All right? So, for example, let's go back to the institutional project. Most institutional projects have what? Steam, medical air. Steam is based on what? Pounds per hour. Medical air is based on what? SCFM, standard CFM. All right? Can you actually use the tools inside of Revit to size a steam system or a medical air system? No, because it's not based on GPM or fixture unit count. If it's not based on GPM or fixture unit count, then shut the calculation off. Revit won't even consider that in the calculation portion. You guys will save yourself a lot of time and a lot of headache as your models grow. So we'll talk about how to shut those calculations off. The other thing is that you can actually limit what you want to see with those calculations. So you can set it up for all, you can set it up with flow only or none. So with flow only, it's basically going to eliminate friction, friction factor, and pressure drop. So the other calculations aren't going to be in there. Yes, question?
And you just also mentioned something about purging. Does that function actually exist in Revit? Because I'm like the only guy that actually uses it in my country.
Yeah, so the question is, does the, and I'm going to paraphrase, and if I'm incorrect, just correct me if I'm misstated or restated incorrectly. But the purging, does that exist inside of Revit? The answer to that is yes. Does the calculations exist inside of Revit? The answer to that is yes. As you're going through your presentation, can you just touch the purge button? Okay. And then, and Adam's going to cover the calculation portion of that. That actually is in type properties, and that's kind of what Adam is going to go through. Okay, so based on that, we're going to flip over. Adam is actually going to go through the product.
Let me make a note.
That's all thinking the same calculation through the whole building makes sense to a point when we start running different noise criteria.
So noise criteria, so calculation is only going to be based on, and we'll get into that, but noise criteria is not one of those. So you won't get regenerative noise anywhere inside of Revit. So it's not going to tell you what the radiated noise out of the duct system is. I see where you're going with this. Yeah. Yeah.
That's the issue our engineers struggle with because it's like box stock doesn't work for everything. And like you said, let's go to a hospital. A hospital has different criteria.
Correct. Yeah. So the question is that can you incorporate noise criteria into your ductwork sizing, correct? In summary, right? The only way that you're going to be able to get around that is if you're, in years of experience, I worked with a couple acoustical consultants. Obviously, you have certain areas, and they basically say nothing more than 750 feet per minute or whatever. You can actually set that to size that particular system at 750 feet per minute, but that's probably the best that you're going to be able to do. It's a manual override, and we'll talk about that when we get into the duct and pipe tools. Okay, with that, I'm going to turn it over to Adam, and he's going to walk through some of the things that we talked about as far as the calculations, the template file, and some other things.
All right, so like Daryl mentioned, we like to keep our file size down too so that we're not hypocritical and have this ginormous file that we're going to send to the architect. So we don't like to fill our file with all kinds of different systems that are not necessary for every type of project or every typical project. So if we go down to our families list in our project browser and expand the pipe systems, we'll notice in here that we've only got maybe a couple handfuls of systems in here. And we also typically put some kind of letter distinguishing the discipline in front of most of our elements, and this helps if you've got a large drop down. You can easily scroll to the right area that you want to be in to choose your system or whatever element that you're trying to place. All right, so now I'm going to get into creating a new piping system, and like Daryl mentioned earlier, if I want to create a condenser water return piping system, I'm going to want to choose a return system that's already created to start from. So I'll select this hot water return system, right click and duplicate. And then if I double click it to get into the type properties, I'm going to want to rename it. And we call ours CHR. Now if you notice, you got all kinds of different settings in here available to you. You've got your graphic overrides where you can set a color for it, a line type pattern, a line weight, anything you want to. I'm just going to leave it this pinky red color for now. And you also have the option for materials. We don't typically set materials because it doesn't affect how the calculations work. It's mostly just for the look of it when you render it. All right, here's the calculation section that Daryl mentioned. For this system, I'm going to leave it set to all. You've got the option for flow only or none. You can turn it off. That's where you actually turn off the calculation. All right. Here's that system classification that we mentioned where we want a return system, and you'll notice that I don't have the option to change this once it's created. So that's why you want to start with a return system to begin with. And then you also have options to select your fluid type. And for this system, I'm going to leave it water, but if you scroll down in here, you'll see you got all kinds of different options available. And again, those are available inside of your mechanical settings for pipe. And then you've got your fluid temperature. Now for our chilled water return pipe, or condenser water return pipe, excuse me, I want to set this to 95 degrees. And it won't let me select or enter 95 degrees. Does anybody know why? I'm sorry? It's not defined, correct. So if we want to define that, I'll show you here in a second after I finish running through here the other settings available. And you'll notice that as soon as you make a selection for your temperature, the fluid viscosity and density also change to match what's in the pipe settings inside the mechanical settings dialog. We also have the option to set an abbreviation in here. And this is useful if you're using a tagging system. You can just set the tag to pull that information. And you also have down at the very bottom all of your rise drop symbology options. If you want to make any changes, that's where you would do that. And again, that's just for the CHR type, pipe type. So if you've got other pipe types that you want different types of symbols for, you can do that per system. I'll hit OK and go into the mechanical settings to the sizes. Oops. Where was I? I'm sorry, temperatures. We want to create a new temperature that would be 95 degrees for the system. So I'll just hit new temperature and set it to 95 degrees. And for the sake of time, I'm going to leave the viscosity and density alone. You would have to calculate that, obviously. All right, so now that I've created that, if you want to create any others, go ahead and create them here. And then once you're done, hit OK. And if I go back into that CHR family type or pipe type, I now have the 95 degrees available. So I can select that and continue on. Any questions?
So the question is, does turning off the calculation significantly speed up Revit or not? The answer to that is define significant. Your significant and my significant. Noticeable? Yes, it can be noticeable. But is it going to, are you going to take a 5-minute load time, turn off all the calculations and make it a 10-second load time? No. But it will have, you can notice that moving around or doing some other things, especially when the view regenerates, may be a little bit faster.
You'll mostly notice that when you're connecting things together inside of your system, because that's when it actually does all the calculating.
Question?
Obviously, you guys don't have every pipe system out there. You're showing us how to do a duplication. Can you just pull one from the template file?
You could. Yeah, so the question is, go ahead.
Yeah, so we can define it all in a template file, store them there, and have our 7 common ones here. Then as I need my specialized ones.
You could, sure. Yeah, you could transfer, but remember, you could, you'll end up transferring all of them. You won't have the ability to go through. No.
You can't pick
Not like,
individual ones now.
Yeah, it's not like AutoCAD MEP. I mean, I didn't say that. It's not like maybe some other products that you used.
Yeah. Now, that's not saying that you couldn't just bring in every system from your other template file, but because you could always just go back through and delete the ones that you don't need very easily if you're in that process anyway.
Yeah, so one of the things that, and the reason why we bring, yes, go ahead.
Once you pull them in, if you don't have the temperature already defined in the template book, right, that new temperature, in, like you just define the 95 degree temperature. If I don't happen to have that in the board, and I drag one in that has the 90,
It should pull that. I would think it would pull that forward. Otherwise, it'll pick one right next to it.
Yeah, I would think it would pull it forward as well. Can you confirm that, Eric? So the question is, if the temperature is not set in your project and you transfer project standards and you have that 95 degree temperature coming over, will it actually bring the density and the viscosity over? Okay, all right, so it should, but we haven't tested that and I don't have any knowledge base of that, so it should. All right, the reason why we're focusing on some of this stuff is understand that our firm is dealing with some files that are about 750, 800 meg in size. So it sometimes can be very difficult to navigate around in a file that size. So we're constantly looking for ways to keep that model smaller, more manageable, and certainly not loading up a template file is one of those ways. So understand that as well. It's not that you couldn't do that, but as your Revit knowledge increases, as you do more Revit projects, the size of your projects are going to go up and you're going to need all the help you can get as far as navigating around in some of those models.
Okay, one more thing we wanted to touch on was vent piping. And if you'll notice, when I go into our vent system, we do not have calculations turned on. Now that may or may not work for your company, but we do not typically calculate the vent fixture units. And so that's one less thing that Revit has to calculate as you're changing the piping and connecting things together. I'm sorry? Oh, sorry, yes. It doesn't choose, you can't choose what type, but since it's a vent system, it won't let you. The last class I was in, they were talking about using just using the sanitary system and calling it vent, and they were still calculating, but that's something that we don't typically do, so why not use the vent system that's already in the product?
So how are you sizing the vent?
Our plumbing engineers haven't fully come to the table yet. They need a little bit more reinforcement from people above. So, Adam, can you show the purge before?
Yes, I will.
You mentioned on the hydraulic return and supply, there's behaviors. One, I guess the supply knows it's going away, it's going towards the equipment, and the return is going away from the piece of equipment. Does the same apply to domestic hot water return?
Yeah, so the question is, based on the behavior, supply and return, going away, coming to, what have you, does the domestic hot water follow the same rules? Yeah, remember it's based on supply, return, exhaust, so those system classifications are hardwired, can't change them, can't add to them, so just make sure that you grab the right one.
The hot water return is not a system family, it's a system family.
The hot water return is not a...
You're talking about the domestic
Yeah,
hot water return. Yeah, it's just domestic hot water.
So should that be hydraulic return?
No.
Yeah.
This one is plumbing. Are you talking about? Yeah.
Yeah, so system classification, so what we're focused on here is supply, return, and exhaust, because we're talking about ductwork and some piping. And when I say piping, I'm referring more to mechanical piping as opposed to plumbing. So within plumbing, you have sanitary, you have vent, you have storm, and domestic water, and I think there's eight total system classifications, eight or nine total system classifications, but you're going to have to select one of those that best or closely matches what you want.
Yeah, we don't use the hydronic return, we use the domestic hot water. And then we classify it through using the system.
Yeah. And yeah, and you're absolutely right, because I didn't clearly clarify that I'm talking about mechanical piping, supply and return. I kind of mentioned plumbing, and we've talked about plumbing, but it's kind of a different animal. Okay. That's correct. And that's, so the comment made up here is that it's a night and day difference between code and designing by what's a chart or a table or what's inside a software product, and that's absolutely correct. So if you're designing by code, it may be a state-driven code, which you may not be able to use this product in regards to that on the plumbing side of things. Okay?
All right, one last thing before we get into the purge. We mentioned earlier that when you draw a pipe and you need to set a system for it, once I draw this and select it, or actually I can do it as I'm drawing it, that would be better. You'll notice that here's our drop down for all of our system types, and I don't want to sit here and scroll all day, so that was the other reason for keeping the list small. This is the scroll bar that I was talking about. Now, if we get into the purge functionality, this is the purge dialog, and you can find it on the Manage tab. And depending on your file size, it might take quite a few minutes to open up. Just let it do its thing, and it'll eventually pop up. But you'll notice in here that I've got 214 things that I could purge. Do I want to do that? No. Because more than likely, since this is a brand new project, these are the things that we want in there. And it's also not a good idea to just blindly purge types of families. Let me find a good one in here. Say like, I'll just theoretically, if you have a receptacle family with all kinds of different types in it, maybe for special outlet, double duplex, what have you, you don't want to purge those individual types out because we've noticed a lot of times it's very hard to get those types back into your model, even by opening it up from the library and trying to load it back in. Sometimes those types just don't come back. So it's very important to make sure that you're only purging entire families, and you want to make sure that those families are ones that you want to get rid of. And if you're getting rid of a whole family, it's very easy to just load it back in anyway. Was that did I answer all the questions on the purge?
No, I think you've got everything covered. So according to my calculations, it was a pun since we were talking about calculations. Apparently everybody's fallen asleep. We've got about a half hour left. It's going to probably take us about that, and I want to save some time at the end for questions. Adam and I will stay around after. There is another class coming in. I actually have to go assist in another class, so we can probably stick around for about 10 or 15 minutes answering questions very quickly.
One thing I'll throw out there about the conversion, especially if you're doing vector files, it's not nested. It's like the old days of AutoCAD where you have to purge through.
Yep. Yeah, that's a good point. So the comment over here is that don't think that, I'll summarize, don't think that a single purge will be enough to solve your problem. It may take 4 or 5 purges to get everything out.
It used to be that you could just hit it once. I think in 2012 they started adding a lot of materials, and I forget what the subcategory is that goes along with that, but when you hit the purge one time, you go back into it again, and you'll notice that all of a sudden there's still materials hanging out in there, and you can hit it again. And you might take like 5 times, depending on how far down you want to go.
So let's move forward. Let's talk about some things that will trip you up even before you get to the duct and pipe tools. We touched a little on this very early on. We talked about disconnects. If you do not connect your piping or your ductwork correctly, you will get disconnects. You cannot use those tools until those disconnects are actually addressed. So you're not going to get full flow through your system if your pipes are disconnected. So you'll see a common theme here is that Disconnects lead to poor model performance. Poor model performance leads to frustrated users. We all like frustrated users, don't we? I know Adam and I love frustrated users. Job security.
Exactly.
And it contributes to less project profitability. So stray, duct, and pipe. So Adam kind of drew that pipe out there in that example. You got stray duct and pipe out there. What's it going to do? It's going to generate a warning. Okay? Again, common theme, warnings are bad. The other thing too that we noticed, we had a project going out, our plumbers, bless their little hearts, they said, hey, you know, this model is really performing, you know, it's behaving badly. So I popped it open, took a look at it. They were under a lot of pressure to get the project done. How many people have ever experienced that? Wow, okay, so just a few of us. All right. They were under a lot of pressure to get the project done. What did they do? They cheated the system. Yeah, I got that pipe close. When it prints, guess what? No one will know. Well, guess what? The model told on them. Okay? Because when I got in there and I took a look at their sanitary system, they had 436 sanitary systems. Okay, so that contributed. So when they started regenning, it was just the spinning wheel of death for about 15, 20 seconds waiting for that view to regenerate. So you got to also cap those pipes. Capping the pipes is an effective way of getting rid of those warnings. Loss definitions. Yes.
Yes.
If you do cap both ends, the system goes away. That actually is something that we also discovered as well as a performance warning. Mike calls it a bug. I didn't call it a bug. I just call it a performance warning. Loss definitions. In order to use some of these tools, the system inspector, the pipe and pressure, or the pipe and duct pressure loss report, you'll need to make sure that you've got loss definitions assigned correctly. How many people use legacy projects to create new projects? Yep. So how many people migrate projects forward? So maybe at 2008, how many, just out of curiosity, how many people have used 2008 Revit MEP? 9? 10? 11? 12? All right, so if you have a Revit project in 2009 and you want to port it forward to use it for a new project in 2013, what are you going to do? Well, actually you can. But what are you going to do? Well, okay, let's not get into the license agreement. What Autodesk doesn't know won't hurt them. Yeah, so one of the things that I'm going to recommend to everybody is do not go from 9 to 13. Do not go from 10 to 13. Do not go from 11 to 13. You can go from 12 to 13. See what the thing is there? Go 9 to 10, 10 to 11, 11 to 12, 12 to 13. When you upgrade 9 to 10, 10 to 11, no, I'm sorry, 9 to 10, get in there and address all your warnings. Go from 10 to 11. There is no question about it. You are going to break things when you migrate that project forward. There's no way around that. Between 2010 and 2011, electrical functionality, I know this is a mechanical class, electrical functionality changed. You migrate that project forward, your electrical systems are kind of hosed. Okay? So just another tip for you guys. Systems, too many systems, we touched on that. Sanitary systems, 430, that's going to drag your model performance down. Also, when we're going to demonstrate this, there is a performance warning in regards to flow, assignment, and pipe, and you need to be aware of this because if you are going to use some of these tools, you got to understand how to overcome this. But basically what happens is if you assign a flow to a VAV box, you got a supply and return pipe. If you have 2 GPM in there and you assign 10 GPM to that, either the supply or the return will update, not both of them until you do something. So we're going to talk about that as well. Warnings. All I can do is stress to you guys, address your warnings. If your service engine soon light comes on, do you drive an extra 10,000 miles? Who said yeah? No book for you. No book for you either. Yeah, 50,000. Great. Okay, just kidding about that. But my point is that if your service engine soon light comes on, that's a warning. You're going to address that. Revit has warnings. Address those. It'll just help your model, help your users. Remember, Adam and I are the only ones that like frustrated users. You guys probably don't. Show disconnects. So you actually, as you're laying out these systems, you can actually, when you're laying them out, you can actually turn disconnects on so you can see where they are so that you can address those as you're going through your system. And then there is a performance warning in regards to the check duct and pipe system, and it has to do with applied templates. With that, I'm going to turn it over to Adam. Adam has about 30 seconds to go through. No, I'm just kidding.
Yeah.
You got about 5 or 10 minutes to go through this. We got a couple other things to cover, and we're going to hold questions until the end, if you don't mind, because I do want to get through the bulk of this presentation.
All right, so I've got here a project that's already pretty well designed. We got piping on this floor plan and some ductwork on the level 3 floor plan. Real quickly, I wanted to show the warnings dialog. You can find that under the Manage tab on the Inquiry panel. And if you'll notice, we've got quite a few warnings in here, about 67 to be exact. And if you notice, you've got your, if you expand it all the way out, you've got your element IDs available in here, so you can go and find them. You can also select the warning in here and hit show, and it'll take you to your view where the actual element is. And then real quickly, that select by ID tool is right here on the inquiry panel also. Just type that in there and hit show. You can also type in multiple IDs with a semicolon separating them to select a group of elements. All right, so with that shown, I'm going to turn on my show disconnects, and you can find that under the Analyze tab on the Check Systems panel. And I'm just going to turn on the pipe ones for now. And you'll notice I've got a few of them hanging out there. And the main one I want to focus on is right here. Again, if you click on any of these warning icons, the little exclamation marks, it shows you what the warning related to it is. And this one says the element has an open connector. All right, so to clear that warning, you can connect it into your system or you can cap it. I'm going to cap one of these ends. Correctly cap it.
It would be it would be try it. Sorry. So the question is show disconnects.
You're off.
All right, we'll try this again. First time presenter. I'm just kidding. The question is show disconnects a user property or a project property? It's a project property.
Yeah, if you leave it turned on and save your project and get out, the next time you get in or anybody else gets in, or even if they synchronize, disconnects are going to show up on them. All right, so I've capped that end, and you'll notice that the warning went away. And then I'm going to connect this into, oh, before I do that, I want to show you something else here. We mentioned earlier that you want to keep your systems, your quantity of systems down. And since this was drawn by itself out in the middle of nowhere, and it's not connected into anything existing, pre-existing in the project, you'll notice that the system name is Heating Hot Water Return 3. That's just the one that Revit gave to it as you drew it. And I'm going to connect it into this Heating Hot Water Return system down here, and you'll notice that it's named Heating Hot Water Return 2. Now, if I actually connect those in, connect this one into the existing one that's already drawn, you'll notice that the disconnect, or I'm sorry, the show disconnect warning disappeared, and also that this pipe that was on system 3 is now on Heating Hot Water Return 2. So it does update for you, and that is one way to clean up your systems.
Yeah, real quickly, in regards to the project that I referenced with the 400 sanitary systems, we actually did have our plumbing department went back, they took our recommendations after the project went out, they went back and cleaned up their model, and they said by the time they reconnected everything, it dropped the total number of systems down like 5 or 6, which is where they should have been. But they basically agreed that it was their mistake that the performance of the model was where it was supposed to be without that. So understand that does have significant impact, especially if you're dealing with 400 or 500 systems in your project.
I had a crash.
Well, this is crash and burn.
Yeah.
Is that a generic annotation family you have?
I'm sorry?
Generic annotation family you have?
That is actually a title block.
That's a title block.
Yes. That way we could pull in the project information. Yep.
Yeah. Yeah, that's actually our Save Here view. You guys, how many people use the Save Here view? Okay, so it's not one of the things why Adam's trying to recover. Take a look at the Save Here view. It's a way that you can actually open up to a standard view every time, as opposed to a very complex view based on the way the person last saved the project. So why Adam is doing that. Let's see if I can butcher a name again. You guys are killing me. AKF Matthew, and I'm not even going to try it. All right, so your book's up here. What was the last name? Exactly, that's what I said. So we had an unexpected glitch here, but
All right, we're back up. Let me get back quickly to where we were. Yeah, if you notice, that was already turned on. That was strange. Graphics error. All right, so I'll leave that system alone. We don't really need it for the rest of this presentation. All right, so now we're going to open up this level 3 and look at the ductwork. I'm going to skip around from the presentation just to kind of keep my going back and forth between views cut down. We don't need to see the pipe disconnects because we're working with ductwork now, so I'll turn that off. All right, and so we want to talk about loss definitions. Now, we've noticed just a little background information on this project file. It was actually upgraded from 2012, maybe even 2011. I'm not the owner, so I don't know that fact. But I do know it was upgraded from 12. And if I select this little takeoff fitting right here, you'll notice that I have a warning associated with it. And if I click the Show Warnings button and expand it, it gives me my information about the fitting, but it also says no loss defined. Now, we've noticed we've noticed some issues where information is not being pulled forward, like Daryl mentioned, from version to version. And this is one of those things. If you select this fitting and try to set the direct loss, you'll notice that it's already set. The loss method is already set to coefficient from table. But if you try and select the ASHRAE table that is for that, there's nothing available. And that's the issue that we're dealing with when you upgrade. So for this presentation, I'm going to set it to specific loss and set the pressure drop to 1 inch. And you'll notice that now that warning is gone. So we cleared out that warning. If you've got a whole bunch of them, you can select all of them at once and set it for all of them to make it more quick. Also, we want to use the check duct system tool. So if I select my medium pressure system over here, and I want to hang on. I don't Sorry, the minimized panels are screwing with my ability. All right, so I want to turn on the Check Duct System tool. If I click it, you notice that nothing really happens. It should stay highlighted. Does anybody know why it's not?
No,
No.
actually, this is a defect.
This is a performance warning?
Yeah, performance warning. Mike calls them defect. I call it performance warning. That you just need to be aware of.
Basically, the workaround for this is in 2013 they started introducing the assignable view templates, and that is what's screwing with our Check Duct System tool.
How many people use the assignable view templates? Okay.
So to get around it, all you need to do is clear the assigned view template, and then all of a sudden the tool works like it's supposed to. And you'll notice that here are the web lines that are supposed to show up and the warning bubble that is associated with that.
And as near as we can tell, it's only the mechanical template when you apply that view. The other ones work fine.
All right.
During the section, when I first got into it, I think the section was turned off. Section or something was turned off.
Section markers?
Section, we went in and had to go none for it to work. When we first went into it,
Oh, yeah.
couldn't do the section.
Section markers weren't turned on in VG.
They were
Right.
turned off and they default.
Yeah.
Yeah.
We went
Default.
through and extensively customized all the view templates for our projects. Because, yeah, you don't know what... you
So
never
la-
know what you're going to get out of the box.
I gave it a shot. I beat the default.
Right. Yeah.
So last thing can you show is the GPM issue,
GPM. I'm sorry.
level 2. That
Yes, yes. The other performance issue that we call it, and Mike calls it a bug. If you change your flow for a VAV box like this, where it's not just VAV boxes in general, it's anything that's got two connectors on it that are pushing information out of two separate entities or two separate connectors. So if maybe I want to set this to 10 GPM. And you'll notice that only the return side updated. Well, the workaround that we've found that seems to work best is you can run the you can run the pipe sizing tool, or you just need to modify the pipe somehow to make it recalculate.
And in modifying the pipe, in this particular case, dragging it either left or right does not do anything. You actually
Right.
have to move it
See, if I just
up or
move it,
down.
it doesn't
It's
change.
basically in the direction that the pipe is drawn.
Basically, you're just forcing it to redo the calculation because you're changing the length, which is part of the calculation.
Okay, so that's some of the things that we have found that you guys also need to be aware of if you're going to use that functionality. I know Autodesk is working on that, but just a little bit of a heads up to you on that. Flip me back.
You want to go through duct sizing?
No, just let's go to the tools. So we've got about 10 more minutes, which means we're going to have to do this last portion in 5 minutes. So we're going to do some really fast work here. Last thing I want to cover is the duct pipe size tool. So again, just kind of reinforcing calculations. We talked about it. Get the engineer over the hump. Get them to believe in the product. Get them to connect the system correctly, whether it's duct or pipe, and then you can use the duct and pipe size tools. And that will allow Revit to do some of that heavy lifting for you. So you can actually size an entire system based on flows, static pressure, velocities, frictions, what have you. You can actually use the duct and pipe pressure loss report to gain a better understanding of what your system is. Remember, I'm going to stress this to you guys, Revit MEP is not here to replace the engineer. It is merely a tool to help you get your construction documents done. Okay? You still have to play engineer. There's no question about that. You're not going to be able to get around it. But you know what? As I'm analyzing a system or looking at a system, it would be great if somebody pointed me in the right direction. So as long as I do some of these things, I can get pointed in the right direction, and then I can come back and reevaluate whether I believe that direction or not. Okay? It just helps me get down the path a lot further and a lot faster. Okay? We may or may not be able to get into the duct pressure loss report, depending on how fast Adam is. The system inspector tool is another tool that will actually show you your critical path. So what you might assume is a critical path may not be a critical path based on the information that's available in Revit. So that, again, that can point you in the right direction as well. You can go through and take a look at that analysis. And also, if you don't believe it, you can go back and recalculate it by hand. Okay? But at least you have some idea where to get started. That's half the battle. All right? And then finally, color legends. Again, you use some of these tools. You can actually apply a color legend to confirm some of those things that the tool did for you. So with that, I'm going to turn it over to Adam.
What am I going through? Sizing?
Yeah.
All right, so we'll go through duct sizing real quick. So if I've got my medium pressure system over here, and I select it, and I go to the Analyze tab, or I'm sorry, the Analyze panel, I can select this duct pipe sizing tool. And you've got options in here to do either or, you know, velocity friction, equal friction, static regain, or you can do just one, or you know, there's a lot of options available. We're going to select static regain for this presentation, and I'm going to set it to 1800. And I forgot to mention this. You also have options in here to when the program goes through the sizing, it can you size it based on calculated size only. It'll match the connector size, or it can do the larger of connector and calculated. You also have the option to restrict height or width by a certain dimension. I'm going to leave that off for now for this presentation and hit OK. All right. Now you'll notice that it did actually resize that based on the 1800 CFM. And I want to make sure that everybody understands that this only works when your system is properly connected. If you've got things that are disconnected or things that don't have flow associated to them, you're not going to be able to use the tool the way it's intended. All right. Now I also wanted to show a quick little color legend for duct.
And before you do that, can you go into the system inspector?
Sure. So if I go back to my piping system, or piping plan, I wanted to go over the system inspector for you guys. So I'll select the supply system on here, and I want to turn on the system inspector from the Analyze panel. And you actually have to turn it on here also. And you'll notice, can you see it up there? Yeah. Your critical path is outlined by
So your critical path was outlined by a red line. And so what happens is that, again, you can get pointed in the right direction. So if you use the system inspector tool, it will graphically show you where that critical path is. If you take your mouse and you hover it over the pipe, it will give you some information if and only if what? Calculations are turned on. You turn calculations off, system inspector tool doesn't work if you turn it off for that particular system, okay? Because it's basically saying, there's nothing to report back to you, okay? So the blue path is the non-critical path. So again, system inspector is a handy tool that will point you in the right direction. We have about 5 minutes left. So if Adam can get this to
all right, so you'll notice that the red outlines our critical path. And you'll notice in here there's a section 3, this is section 3, this is section 9, section 2. If you're actually running your duct loss or your pressure loss reports, it'll call out those section numbers. And this is where you know what that section number means from the report. So I'm going to go ahead and place a tag on here that you just click wherever you want to place it. And you'll notice that if maybe you don't want that one anymore, I can choose over here. And you'll notice that the previous one disappears. That's also true whenever you click finish or cancel, the tag will disappear and your critical path will disappear and all that, and it'll go back to a normal looking plan. But real quickly, I wanted to show if I change the static pressure on this, I'm sorry, the pressure drop on this to say 10 inches, and then I run the inspection again, you'll notice that the critical path changed. It used to go all the way down here, but now it's going up here because it took that pressure drop into account.
So at least the tool is behaving as you would expect. So again, obviously one change, again, it's pointing you in the right direction. The thing that we're not going to get into, and I apologize, we just ran out of time, but we're not going to get into the system loss reports. There are some other Revit MEP classes going on, and I did look at the schedule, and they are actually covering the system loss report. So even though you didn't see it here, since we're only the third class of the day, more than likely you'll see that before the end of the week. So real quickly
also, you've got the volume available for your system right here. If you need to size your tank, your pressure or expansion tank, that's readily available for you. It's also available on the system inspector.
How many people love sizing expansion tanks? Computing? What is wrong with you?
Live for it.
My gosh. Okay. So yeah, you have to go through a lengthy process of figuring out what the volume of the system is. There are some tools out there, but at least if you've got things connected, you can actually tell what the volume of your system is. So real quickly, did not get to duct pipe pressure loss reports. I apologize. I do know that there are some Revit MEP classes that are going to go through that. We didn't get to the color legend. You know, color legend is basically a great tool to apply to your view to show or to confirm some of those tools that you use to size your ductwork and piping system. So last thing, one of the things that we covered, or one of the things that I covered at the very beginning of this, is the class summary. So I'm hoping that you guys now have a better understanding of calculations. You understand where those calculations originated from. You understand how they get into Revit MEP. So if you have any people who are resistive of change, you can then do like what we do. Give me your hand. Let's walk through this process and give them that sense of ease. The other thing too is we kind of touched on some of the duct and pipe tools for routing. We talked about System Inspector. Unfortunately, we didn't get to the duct and pipe pressure loss reports or the color fills. But anyway, last thing that I want to do is I need Tori to actually draw two names out of the hat. Oh boy. So we have Erica Compton. Okay, there's a book up here for you. And Jessica Eli. Okay, there's a book up here for you. Actually, you're close. Delivery is free today. Okay, any questions? Questions before you guys depart? Yes. I'm sorry?
How about ventilation where you've got rockwork